So good afternoon, everyone. Good morning and good evening for those who are on the other side of the world. My name is Jonathan. I'll be today your MOOC scout to introduce Sally Brown and David Obura, who is together with us today. Sally Brown is a senior research fellow at the University of Southampton. Her interests include physical and social interaction at coastal zones, focusing mostly on sea level changes, including impacts, adaptation, policy implications, and coastal engineering. Her research has taken her all around the globe, including the Maldives, China, Ghana, India, and Bangladesh. We have also David Obura, who coordinates the CORDIO, that's the Coastal Ocean Research and Development Indian Ocean. It's a non-profit organization based in Kenya and working throughout the Western Indian Ocean. His research focuses mainly on maintaining and increasing resilience of coral reefs in the face of global and local threats. CORDIO works extensively on reef fisheries as well. David is chair of the IUCN, that's the International Union for Conservation of Nature, and he's a coral specialist within this group. Hello, David, and hello, Sally.
Hello.
Hello.
So, Sally, I would like to start off with you. Having worked so much on the issue of sea level rise and its impact on coastal cities around the world, how diverse can the solution space be for the adaptation and mitigation factor?
I think the solution space can be very diverse. We have to appreciate that every city, every coastline is different. And so it means that if you look at adaptation or mitigation, it means that one size won't fit all, and we have to consider the needs of each location. So, for example, in more rural areas, it could be that we concentrate looking more at wetlands and wetland remediation, planting new wetlands in order to encourage climate change mitigation, or encourage wetlands to absorb the wave energy, so actually it doesn't actually reach the land itself. It acts as a buffer. But when we come to cities, the solutions can be very different because the value of the land there is so much more. So we might have to think a lot more about hard engineering structures like building seawalls, raising land where necessary. It's not going to be like a single solution. It has to be thought of throughout time. It has to be thought of as a whole system. So we have to be very careful that if we do one thing in one place, it doesn't adversely affect another.
Thank you, Sally. David, you're working at CORDIO. Would you tell us a little bit about your activities and what do you undertake at CORDIO?
Okay, thanks, Jonathan, and hello to everybody listening. It's great to be here. CORDIO is a non-profit research organization. We're based in Kenya, and we focus on coral reefs, but that's just where our expertise is, but more generally on marine biodiversity and resources. And we do research on the ecology of coral and reef species, fish quite a bit. But then we also do a lot of fisheries work as well, because we are mostly working on applied questions in coral reef sustainability and management. So fisheries is a huge area dependent on reefs in the Western Indian Ocean. And then around the fisheries work and around our understanding, we interact a lot with marine protected area managers and also with the fishery management for coral reef fisheries. So we try and cover the broad base from biology through to resource use and social science, where we can, and interact with policy and management communities to try and best achieve and conservation of reef resources. Now, the thing with the marine environment is, of course, the ocean is huge and very connected. And so at the national level, we work as much as possible at the regional level with partners in different countries around East Africa. And we have 10 countries really or 9 or 10 countries we interact with under the UNEP Regional Seas framework over here. It really matches the scale of coral reef dynamics in our region. and try and get sort of integrated and very aligned management and conservation across the countries over the year.
You mentioned coral reefs and reef diversity and health, etc. We have a question here from Marvi from the Fiji, who's asked in the forum, what exactly do you mean by reef and healthy reefs? How do we assess whether a reef is healthy?
Well, assessing whether a reef is healthy, of course, that's a very topical question right now. Of course, it's a complex thing to try and measure, but at the same time, it's quite relatively simple. I mean, you need to measure various components of the coral reef community, and they need to be all interacting with one another and productive in terms of their biomass and their internal dynamics. What we tend to do is we measure the cover of corals and algae on the bottom. Of course, we need to have a certain amount of coral for it to really qualify as a coral reef. And then there's quite a diverse community of invertebrates and fish and other species that depend on the corals. So these things can be measured by scientists, but also by marine park rangers and also by community members. There's a huge amount of participatory monitoring that's happening around the world now, especially where fishing communities are monitoring their own reef areas and resources, or else divers and tourists are monitoring things while they dive. So there's a range of indicators that have been identified, and we understand in general terms which are the best ones to use, but trying to process all that information is very challenging. But reef health, it's basically if the reef has a lot of different species, there's a lot of interactions between them, and you can see that it's healthy, and you can see it declining when fish are removed from the fish by fishing, or else if water quality is very poor and the water is polluted and corals are declining. And you can see it, and so it's a challenge to make the measures really show well what we know intuitively, and then to formulate some responses around that.
All right. Sally, I have a question for you on this one. Coral reefs has the ability as a natural protector to protect island nations. Sea level rise is one of the main threats to many coastal cities and island states. From your experience, are people aware of sea level rise at their coasts and how vulnerable they can be?
I think yes is the very short answer. People who live on coasts are aware that the sea changes at hourly intervals, at daily intervals, at weekly intervals, monthly and yearly intervals. And I think those people have different levels of vulnerability, different levels of awareness, according to how much they're affected by the sea. So, for example, in some small island states, they're very, very highly affected by seasonal variations, and they get regular flooding. So there's very high awareness there about an everyday basis, and therefore that concern extends for a long time, and very certainly with sea level rise there's long-term concerns about what those islands will do. Other islands are perhaps a little bit less concerned. Maybe they're sort of higher and rockier, and therefore they are actually sort of, relative to the level of sea level, they're actually higher at a higher elevation. It doesn't mean that they're not concerned about sea level rise. It just means that they have a slightly different relationship to the actual problem of rising sea levels, but still very, very connected to their marine environment, including corals.
Thank you. I have a question here from Nicole Wirth. She's asking about the Great Barrier Reef. Yesterday, even I was reading something on the news about the Great Barrier Reef, and it's worth $40 billion US. It has been estimated. So a question is, it is in bad condition. In particular, she wants to know the difference between the reaction of cold water and warm water corals towards climate change.
I guess that's a question for me then. So
yes.
that's quite a big question. So the difference between warm water and cold water corals. So climate change in the ocean has two main, or in terms of coral reefs, you have the warming of seawater, and warm water corals are pretty close to their upper limit of temperature. So as the water warms any further, they become stressed, and it varies from place to place and among species. But they are all basically very sensitive. The other aspect of climate change that's important is when CO2 or carbon dioxide dissolves in water, it becomes more acidic. And because corals secrete calcium carbonate, their skeletons are very vulnerable to more acidic conditions, and it requires a lot more energy to produce those skeletons. So corals, both warm water and cold water corals, are very vulnerable to acidification. Now the thing is how warming and acidification progress in different parts of the world, and cold water corals tend to be deeper. Of course, in the shallows, in the more sort of temperate and polar regions, within the tropics, are only found very deep. How acidification and warming progress is quite different. And I think because of the accessibility of warm water corals, we actually understand a lot about the vulnerability of warm water corals to rising temperatures. And now it's really just a question of at what point these corals really become overstressed and this ecosystem starts to change, rather than if it will. Whereas with acidification, there's still less that we know about the dynamics of how corals and other species will deal with acidification.
Thank you. Sally, we have another question here from Nicole this time again. She asked earlier, what is coastal engineering? I introduced you as interest in coastal engineering, so she wants to understand what that is. Would you explain that to her?
Of course, that's a very, very big question. So engineering can mean anything that where humans change the coastal zone. So engineering can be very simply mean building hard structures. So that's things like groins or breakwaters that sort of stick out at right angles to the coast. It can mean sea walls which run parallel to the coast. Coastal engineering can also mean softer forms of engineering, such as beach nourishment. So placing sand, beach or foreshore to actually reduce erosion or flooding. You can get more sort of green types of engineering, which means sort of engineering wetlands, creating new wetlands, and also involved in a sort of very, very broad way, marine spatial planning and sort of the land planning as well, to try and engineer better environments or lower risk environments for people to live and enjoy. So it can be a huge range of factors. Generally, though, it is more concentrated on sort of the harder structures and infrastructure rather than the sort of the greener side. But that's a growing field.
Thank you. I'd like to pick up a little bit on the issue of climate change and the relationship with both in terms of sea level and also coastal coral reefs. There are various factors that affect coral reef health, which we've seen that already. For example, natural disasters or even national climate variability, like ENSO or the Indian Ocean dipole for the Indian Ocean. I was wondering, what sort of stresses are human adding on to coral reefs, for example, due to coastal activities? David?
Well, basically everything. I mean, as I saw a little bit of the introductory video for the coastal section, and the idea that, you know, rivers are like the veins, I suppose, delivering everything that comes from the land into the sea. And through rivers and groundwater, and then construction on land and coastal hardening and so on. I mean, the coastal zone in general and coral reefs in particular experience so lower water quality. That's both from nutrients, increase in nutrients, chemical pollution, and sedimentation, sediments that get delivered from land. In addition to that, the fishing and the alteration of the ecology and the community structure of reefs is very important from fishing activities. That kind of extraction really does change the dynamics completely. And then on top of that, of course, is the larger scale issues around climate change and warming and acidification and so on. And I think the key thing that we're realizing now, beginning to understand, is that certain things we can't do much about at the local scale, such as the climate change influences, where that's all about the amount of CO2 in the atmosphere. So there's not much you can do locally, and even all the actions we do now to reduce CO2, we're still locked into several decades worth of the lag effect of the CO2 that has been released up until now. So even with that, we have a huge burden or a huge need to reduce the other stresses that are more localized. So from sedimentation, from pollution, coastal hardening, and engineering, things like that, to ensure that the cumulative impacts on marine ecosystems are alleviated as much as possible, to give them a chance to get through the various climate stresses that are going to increase in the future. So there's a huge range of different factors there, and perhaps Sally would want to add onto that, because that combines some of our areas together.
Yeah. So the only coral reef I've ever visited has been in the Maldives, and I've been lucky enough to go there twice. And one thing that I noticed was coral bleaching from changes in the water temperature with El Nino. So that's one threat. The other threat that I've seen and also heard of as well is actually the threat of from tourism. So when we were flying in, we had warnings that don't touch the coral, because if you start to touch the coral, because it's a very fragile environment, the coral can die. And so there is this danger that if we actually interact too much, or we aren't very sensible in the way that we interact, that could actually be an unnecessary threat. So alongside that, there is education to make sure that we're actually treating the coral that is there appropriately and making sure that it is sustainable. Everybody likes to go and have a snorkel and see what the coral's like, but we have to be careful to respect it as well.
But I think, if I can just pick up on that as well, I think one of the paradoxes that we have in how we talk about these things is that we tend to say, or we write, that in spite of coral reefs being so valuable, they are receiving so many threats, so they are being impacted so much by what we do. And I think we have to realize that it's because of their value to us that they're receiving all these impacts, because whether it's tourism or fishing or construction, where people and communities are attracted to live beside coral reefs because they do get so much from them. So we need to shift our attitude to realizing that in order to use these systems, we do have to protect them commensurate with our use, as opposed to thinking about it afterwards.
There's Peter Musembi, I believe, from Kenya, asking two questions, and I think I will combine those two questions for the both of you. In the first one, he's asking specifically, Sally, about coastal engineering and whether or not are there any current sustainable structures available to that can be recommended. And to David, he asks about erosion, but I know, Sally, that you also worked a lot with erosion, so you might want to pick up on that. So he's asking about different methods, because they are experiencing erosion on a beach called Watamu in Kenya. And people have been using different methods, according to him, and he's asking about what are your comments, what are your experience with different methods of mitigating erosions? So perhaps Sally starts, maybe?
Okay, so erosion is a very important issue, and for some people, erosion is actually much more important than flooding. Erosion is also very important in the short term because it's happening here and now, whereas when you think about sea level rise, it's over a much longer period of time. There are two issues there about thinking about what's sustainable and also how do you actually combat erosion. Now, traditionally, when we looked at developing countries and developed countries, one way that you can try and reduce erosion is through building hard engineering structures such as groins perpendicular to the coast. You could also build seawalls as well. And that aims to, if you're building a groin, to increase the amount of sediment in one location, because it reduces the rate or the magnitude of longshore drift, and actually keep sediment in one location. Now that's good if you live right inside of the groins or the groin field, if you've got a number of groins. But the problem is that if you lived on the downdrift side, so on the other side of the groins, you can get increased erosion. And the only way that you could really stop erosion in that place is to build another groin, and it just moves the problem further and further away. Now, we've seen a lot of problems in the UK along the US barrier islands, and it is one of these things that if you start it, it's very, very difficult to stop. I've also seen pictures, again, from a small island where they build one groin and then they have to build another groin, and all of a sudden they have groins all around the island, and it actually changes the natural appearance. So groins can be used in certain locations, but you have to think about the long-term effects and this long-term sustainability. Now, one way to try and get around that problem is to undertake beach nourishment. that can act as a sort of a semi-solution in terms of it looks more natural, but you have to keep topping up that nourishment if you have longshore drift that moves that sediment down drift. I think overall, you also have to consider exactly road. So, for example, road, other coasts will be enhanced if you've got, say, sand mining, or if you've got fences up drift, increasing the erosion. So you actually have to understand the problem as well, not just exactly what the solution could be.
I'll just pick up on that, Sally. What is a groin exactly, and what do you mean by beach nourishment? Just to clarify.
So a groin is normally a wooden or a rock series of rocks that are placed perpendicular to the coast and go out into the sea, and they can go out maybe 100 meters. And what that does, the groin stops any of the sediment which moves along the coast, and the sediment tends to move along the coast parallel to the coast. And if a groin is there, it stops it. It's like a barrier going across the road. If you imagine cars going along a road, the sand is the cars, and if you had a barrier that suddenly came down and stopped everything, then that would be like the equal to the groin, and that stops the cars moving. So beach nourishment is when you've got a lot of new sand or shingle that is placed on the existing beach. And that may be tons and tons of sand that actually increases the beach height, or it increases the beach width. So it means that there is waves don't get to the land so easily.
Okay. David, would you like anything to add?
Yeah, so yeah, prior to that, so thanks, Peter. I know Peter and Watamu Beach quite well. So the case that we have here in Watamu Beach, just to describe it for others, is that it's a beach that's fairly well protected by a fringing reef in front of it. And so depending on the waves and the seasons and the currents, you can have actually quite a strong shift in the structure of the beach and the shape of the beach over the years. And of course, people tend to build now where the shoreline happens to be, not recognizing that that shoreline could be quite temporary. And the beach may either grow over a period of decades, or it may disappear too. On top of that, of course, we do have sea level rise that is affecting that area and many other beaches in Kenya. Now, the most effective beach protection I've seen on these sorts of situations is where at the upper end of the beach, once the sea level rises quite a bit higher, it doesn't really, with sticks sort of stakes around along each other, so in a line. But the important thing is that that line has to be a wavy line, because the critical thing, and Sally may explain this more, is that where you put in so you have to try and make it as rough as possible so you don't just reflect the wave energy back out, because that just carries the sand away. And I've seen this in the Seychelles quite effectively. So where you have these stacks of poles in the beach at ground level, at the upper end of the beach. And as you go down, you put in then another stack a little bit lower down, another stack a little bit lower down. And if these are wavy lines, it can trap sediment behind them. And it doesn't look that unattractive. But in the end, you do have steps and vertical sort of stakes stuck in the ground. Eventually, with sea level rise, it's not going to be enough. Unfortunately, the kinds of places that are considering this along that beach and others in Kenya, they do have to protect their front line, and how to do it against the eventual sea level rise is a really tough question. It's going to be a big issue for them all to face.
David, we have a question here from Mavi from the Fiji again. You mentioned that that humans' effects on due to coastal activities on the coastal region comes in the form of lens interactions such as runoff, eutrophication, fishing activities, tourism, and so on. He's asking a question about what sort of solution and how effective management for fishing, for instance, can help. So do you have any anecdotes? Do you have any examples that could be used that he can have an idea about that?
Oh, yeah. So now at this point, in terms of coral reef management, sort of where you have overfishing, trying to bring in better fisheries management, or where you have a lot of coastal impacts from pollution, sedimentation, runoff, there are some really good examples now around the world of good practices that have worked. And the thing is there, so particularly thinking about fisheries, for example, in the Fiji case, the key thing around fisheries and many of these issues is the governance side. So who is in charge and how do you exert control and things like that. And it really has to go down to the local level in terms of the users and the rights owners. In Fiji's case, you have very strong traditional rights around the coastline. It's much weaker in Africa, for example. So it's a bit more of a challenge for us to develop those sorts of practices. But we're all trying to build up the practices around locally managed marine areas, or LMMAs we call them. There's a great example from Fiji in the Pacific, and now Kenya and Madagascar in the Western Indian Ocean, where basically several years of interacting with community fishers and their leadership, blending the local knowledge with scientific knowledge about the limits to how many fish you can take out. And if there are many more fishermen than there are fish available, then somehow that system, the fisheries system, the communities and the government together have to work out how to reduce the number of fishermen so you don't remove too many. So there are great examples and also on cleaning up pollution and sedimentation as well, and that gives reefs the ability to recover from past impacts. And I think particularly for the community fisheries, the Managed Marine Area Network, FLAMA, is something anyone can Google and look up online, and you'll come across really good examples there. I'm sure they must be included in some of the course materials as well, or could be put into those later on.
Traditional and indigenous knowledge is quite important. For instance, education level is different for different countries. Therefore, the way that people interact with the coast depends on how much they know about it. Has there been any, from your experience with working with people at the coast on site, has there been any way to work along traditional and indigenous population in terms of passing on an education and sensitizing people?
Oh yes, and that is really the standard or the best practice now that is being applied throughout tropical areas and also in polar areas, for example, with Eskimo or Inuit communities as well. Awareness of property rights and of local rights in indigenous communities is increasing rapidly, and they are calling for their rights to be exercised and to have a seat at the table. I think in most countries where this is an issue. And the thing is, I would say it's not necessarily an issue of recording knowledge or comparing knowledge per se. It's much more an issue of the mutual respect and involvement and engagement of the key stakeholders that are engaged in the coastal zone. I think if all are involved and if all have a mechanism for being organized and representing their interests, and then also listening to the interests of other stakeholders, because you mentioned the term marine spatial planning earlier on. The ocean it's not open space anymore. It's basically densely used by all sorts of people. So have everything at once. They have to negotiate and identify some trade-offs and work out who can have what rights and how to make sure that the system functions and one group doesn't hurt the interests of another. I think that's the key thing. But this aspect of really engaging at the community level has really taken off in the last 10 to 20 years. And I think that's only going to increase in the next few decades, which will be good for the coastal environment.
Sally?
I agree with very much what David is saying. The local engagement is absolutely key. In the UK, we've seen it increase again in the last decade. And I think people's appreciation of the coast and the problems that they're seeing on the coast has grown. But it's not something that can just stop. You have to keep working on it. People come and go on the coast, people change, and the coast changes as well, and the nature of the problem changes. So it has to be a continued engagement, and it's as important as doing any kind of engineering, just making sure that people are happy with the solution, people understand the solution, and people know what the risks are associated with the solution. and they need to be guided by experts, but ultimately they still need to have a say and be in control of their sort of coastal destiny and understanding where they're going.
Yeah, I think another really important thing to bring up, which I mean, it's the knowledge holders are key participants in the process to represent their own knowledge. When we talk about indigenous and traditional knowledge, of course, some places, communities have had interactions with the sea going back thousands of years and have built up very complex knowledge systems. In other areas, it may be a few hundred years or just decades. And so the knowledge systems are quite different in terms of their maturity. So it's important to recognize that. And also that we're in a very different place now with global population and coastal populations being where they are now. On the whole, on average, either 10 times or more what they were when local knowledge systems were developed. So we do have to recognize the limitations of different knowledge systems, including scientific knowledge, in order to come to solutions that make sense now with the levels of use and the population density we have now.
David, we have a question here from Cole Keeler, and she's asking the difference in terms of coral reefs recovery due to different stressors. So, for example, she asks, if we do not do anything in terms of human impact, how long will it take for coral reefs to recover? And what are the differences in general terms that will occur because of our impact on coral reefs? So how much more stress do we put on it by interacting with our corals?
Okay, thanks. That's that's a good question. And now we wondered about this. So the first really big global impacts came in 1998, really, with the El Nino, and that was the hottest year on record at the time. What we have seen since then is that reefs that have a high resilience, or innate sort of capacity for recovery for many different reasons, and also that they have minimal human stresses on them, those reefs can recover to a good state within 15 years. Of course, they don't necessarily have the same old corals, old fish, or in terms of the largest sizes. Good coral community is quite diverse and all growing through the size classes. When you start to add stresses onto those, then it slows that down, basically. And I would say, just as a ballpark, with moderate stresses on reefs, you probably double that recovery time to about 30 years. But with high levels of stress, what we're really concerned about now, and you hear this in phase changes, reefs moving into different stables. So it may be that the corals are really unable to recover back to a coral-dominated state, and instead the rock gets taken over by algae. If there's a lot of fish, herbivores, and sea urchins, you can have an algal reef that develops in an algal-dominated state. If there's not much herbivory, that can turn into macroalgae, large algae. There's a lot of nutrients, and that can become reef of algae and microbes and bacteria, things like that. So do greatly affect the ability of reefs to recover. And that's one of the biggest reasons that so if the course is really dealing with coastal management in general, one specific group of marine practitioners are sort of protected area managers, and we tend to look for the best reefs or the best sites that are most diverse and protect their biodiversity. And that's well and good, but as coastal managers, we need to manage the whole coastline, and we need to understand, even in impacted areas, what is the management that we can do to maximize the recovery potential or ability of those coastlines that are perhaps not the most attractive and the best and most diverse, but are very important for livelihoods and for coastal protection and other reasons like that.
All right. Now, when it comes to sea level rise, human impact on greenhouse gases, it's not something we can discredit anymore. It's happening. And even if we stop emitting any greenhouse gas into the atmosphere, we are still going to be feeling the effect for the next couple of decades. So, Sally, in 2015, the Paris Agreement agreed for 1.5 degrees Celsius. What does that actually mean when it comes to sea level? Let's say we assume we reach that level. What does it mean in terms of sea level rise for coastal megacities, and is that different as well for low-lying states? How many meters are we talking about?
Okay, that's a very big question. First of all, I think some of the latest science that's coming out is saying it's very difficult to achieve 1.5 degrees, and that 1.5 degrees with respect to pre-industrial, which is at the end of the 19th century, could be reached by about 2030. And because there's a time lag with the emissions and then the increase in global mean temperatures, it could mean that we go above 1.5. That's looking more likely. So it could be, first of all, that we'd be more aiming for maybe 2 degrees at the minimum level. We then had to translate, so what does that mean for sea level rise? Now, sea level rise behaves quite differently. It's a bit like putting a pan of water on the stove and you turn up the heat, but it takes a long time for that water to warm. And in the same way, if you increase the temperature of the Earth, it means that oceans take a long time to warm. So the effect of the rise in temperature of 1.5 or 2 or 3 degrees won't be felt instantaneously. It might go in for many, many decades or centuries. And that means that sea levels will keep rising for a long period of time. So even with a 1.5 degree or a 2-degree rise in temperatures, we still may see sea level rise of maybe a metre or more, not just in this century, but in the very long term, going beyond our lifetimes. Now that has big implications, big long-term implications, not just for low-lying areas, but for also cities, as you say. I think the important thing is to differentiate between whether we would like to adapt those areas or if actually we can't or we don't want to. So if, for instance, in a city, we know there's high value land, there's a lot of population. So it's very likely that we will start to protect cities very differently to how we do today. So, for example, building higher seawalls or looking at how we can put in different types of flood barriers. There will be some low-lying areas that we actually will decide to protect as well, even if they're very, very rural. For example, if you like farmland, which happens in large parts of Germany and the Netherlands as well, so they might be diked. But there's some places that we know that we can't afford to adapt, either financially or whether we can actually do that physically. And so for those areas, it might be that they actually gradually change. It might be that they gradually start to either flood or the soils get more saline, and that might mean changes in agricultural practices. But there may be some changes that happen naturally. For example, on small islands, if small islands, they tend to grow, coral islands grow vertically. So if you have, say, a storm surge, something that comes and floods land, if it dumps sediment, those islands will gradually grow vertically. And they may keep pace with some of the sea level rise. They may not drown. But we have to actually think, well, what's plausible? What happens if you have very high rates of sea level rise? Because we have to think about all implications and how that affects societies in all different ways.
Sally, we have a question here as well on the same line from Shuli Biswas, who I believe is from the Bay of Bengal area. He's asking about deltas and in particular adaptation strategies that you would recommend for sea level rise in delta regions.
Okay, so again, that's very, very individual for each type of delta. Right. So I think there's different things you have to think about. So first of all, it's not just about size and deltas. You have to consider how much sediment is coming down the river itself, because if you have sediment coming down the river and the river dumps the sediment onto the land if it floods, it means that land level will very, very slowly rise. But if you don't let the sediment, if, for example, the river has no sediment because there's dams that stop sediment moving downstream, or there's barriers, maybe dikes on each side of the river to stop flooding happening, it means that sediment won't go on the land. And so it means that the land may possibly start sinking because it doesn't have enough sediment. So first of all, if you're thinking about adaptation, you have to think about the relationship between subsidence and the amount of sediment that's going to come down the river, but also the amount of sea level rise itself. So it's a combination of the two things. You have to think about, how do you adapt? Where do people live? What do you want to save and protect? So building dikes might be one option, but you also have to think about other wider options, maybe by allowing a little bit of an area to retreat in order to save a wider area of land from flooding itself.
David, I would like to turn to you and ask you somewhat of a personal question. As a scientist yourself, a science manager, a policy influencer, if I may call, you wear different hats, right? What is it like?
Well, it can be very challenging to manage to keep it all going. I mean, primarily I am a scientist and ecologist, and I still get out in the field and do surveys of reefs and so on. And I enjoy that. But I realize that in terms of the multiplier effect, for example, I mean, as an individual, you can only do so much. So interacting in the management and the policy sphere is really sort of managed to influence very much yet, but we're hoping that our science and we are putting together as marine, coral reef and marine scientists and managers is getting stronger and stronger, that our corporations, companies, cities and so on take on the guidance and the best practice that is emerging from many streams of work. So it's a challenge, but it's very enjoyable because it's, you know, I'm able to travel a bit between just focusing on science and being very sort of inward looking in a way, being much more strongly externally to see what's relevant, what's interesting. So I certainly enjoy it.
Sally, I will turn to you as well with a very personal question. I've seen your paper on weather and music. And I believe we spoke about that before as well. So you've been very active with media dissemination of your work and results. Can you tell us a little bit more about that, and how creative can our viewers out in the big wide world be in order to disseminate and spread knowledge?
So for those of those listening, we had this wacky idea. We had a breakout session in a conference, and as a challenge, we were asked to name and list songs that either mentioned weather or climate in some type of way, and we had to name 10 of them, and our group got carried away with the idea and we ended up naming 150. And then for a bit of fun, we decided to keep going and write a paper on it, and we ended up getting over 750 different songs with weather in it. And we thought it was funny, and when we mentioned it to our colleagues, they also thought it was quite funny, and they normally laughed in our face and then suggested a new song. And in terms of engaging with the media thought it was quite fun as well, in that nobody had actually looked at this before. And I think engaging with the media in different ways, it makes people actually think about your research, and actually makes you appreciate how the outside world sees your research as well. And sometimes doing research just for fun gives people a different perspective on what you do. It gives people a different idea that scientists don't just stare at a computer and deal with numbers all day, that you can have a bit of fun and actually relate your work to society as well. And it brought around lots of different opportunities, so that you can try and think about how you promote your work differently on radio compared to if you were doing a piece online. Again, a lot of what we do when we're talking to the media is about telling a story, and actually thinking, well, what's a good story? How does that story relate to people? And how does it make it very, very interesting? So we do hard science. We think about our results very carefully, but we also think about what's the story behind it, and what does that make it? How does that make it interesting to people?
I have, let's turn now to, I mean, since we're talking about public awareness, the Sustainable Development Goal has a target 14.2 that deals with sustainable management and protection of coastal ecosystem to avoid significant adverse impact. Now, in order to do that, they suggest strengthening the resilience and taking action for their restoration, there as in coastal ecosystems. Now, this is to be reached by 2020. A survey from the forum about what people have been telling us what the impression of that target is. We have, for example, some challenges is funding, lack of funding. That comes from James Byrne. David Gillaberg from Spain highlights, for instance, that economy goes first, money goes for port development and not coastal restoration. Similarly is being echoed by Danny from the US. Government has different priorities. Some suggestion has been made on MPAs being developed from the Virgin Islands. Nicola Calhoun talks about success stories in terms of offshore drilling, fish and fish farming. My question to you now is, do you foresee this achievement on this? Do you foresee an achievement on this target by 2020? Can you share any success stories that you've had so far, or what are your personal impressions on that?
So if I just take from my experience so far, I agree with a lot of the comments that you've read out. I've certainly seen examples where development is more important than actually protecting marine areas, and development can actually be more important than reducing risk, and development can increase risk in these areas. And that translates in putting into pressures in the marine environment, which makes that target much more difficult to achieve. We have to remember that it came from small islands, which are actually relying on that marine environment. And that, I think, is because they're much more connected with the sea, they're much more closer to home. But I think the biggest thing I found, and not just in my own experience, but talking with others, is that a lot of it comes down to education. It is to do with finance, yes, it is to do about availability resources. But at the heart of it, if you put education and make people more aware about the marine environment and the connectivities, then engender change. So, for example, one of my colleagues was in a developing country somewhere in Asia, and they were talking about how their work impacts the environment, and particularly the marine environment. And they had waste left over from a lunch, packaging, that type of thing, things that don't biodegrade. Because they couldn't just throw it out, it just got put into the marine environment and thrown into the marine environment. And it really made my colleagues think about, actually, if this is what's going on because there isn't maybe the education or the governance systems that allow people to dispose of waste in a responsible way, that can actually have knock-on impacts. So it's a challenge for everybody, and it's not going to be a challenge that's going to be solved easily, and it has to come from all different directions.
David?
Yeah, so if I pick up on that, then I'll start with, so one of the first questions that came out, which started with what I thought that question was going to be about, which was the statement that the Great Barrier Reef is worth $1 billion, I think, was the number that you mentioned from one of the questions.
$42 billion to be precise.
$42 billion to be exact. So the thing is, I mean, the natural environment is a resource. It's an asset that we gain a lot of benefits from. And I think the more the economic systems understand that, you know, if you actually quantify the benefits received by a city or a business or something from coastal protection due to a coral reef or mangroves, or the climate regulation that happens because of the sea, you see that the actual funding that's needed to manage natural systems should actually be derived from the income that is made or benefits that flow from them. So it's the same in, if you go to a movie, you have to pay for it. So if you're going to benefit from coastal protection, you should pay for it. And that could come through taxes and various other things like that. So I think it is a matter of education, but it's really deeper than that in terms of real value change and understanding the limits of the planet that we're on, because we are exceeding its limits in many different ways. And this is the foundation of the concept of the blue economy, which in a very in a superficial way, many developing countries are looking to the sea and blue economic development as being more resources and more money from the sea. But it has to come with a sustainability component to it. Otherwise, we'll use that up too, and then there won't be anything else to go to as well. So we really have to understand what we get, and to make sure that the benefits that are generated from coastal systems, for example, pay for their upkeep and invested in their upkeep. It's the same concept as a circular economy as well, as realizing that, you know, you can't just take something out of the environment, make something out of it, use it, then throw it away. To minimize the waste as much as you can, so that you recycle and reuse to the point that there really isn't any waste from the activities that are being done. That has very positive elements to it, because there's a lot of opportunities that can be derived from the many different stages in which some product and material can be used in different ways. But we do have to transform our systems to arrive at that. And I think climate change and global population are driving us to the point where at many different scales, we're realizing that we have to come to that quite soon. Succeed in that.
I would like to just pass on a few messages for you, Sally. We have here Isabel Gonzalez and Marvi again from the Fiji talking about music and climate change, and how they've also interacted, and how they've also sort of come up with an innovative way of doing it. But a question now from Marvi, talking about climate change funding. That's a big topic. That's a big issue. So developed countries who have contributed most to the issue of climate change, and small island developed state SIDS who are mostly affected by climate change. Are there anything that you are aware of, any methods of any scheme that you're aware of that channels in funding from the developed countries to the developing countries?
Yes. So I think, first of all, we take a step back. The Paris Agreement, which was signed last year, that particularly mentioned least developed countries and also the small island developing states. They recognise that they have caused they've contributed less to emissions, but also that they need help in adaptation themselves. Now, there are various pots of money, various adaptation funds can help least developed states, small island developing states, and other developing nations. And these different pots of money help and align themselves with different individual or different countries and different requirements. I don't know the details themselves. I think one of the challenges is to try and target that money in an effective way. So making sure that it's not just accounting for like a big change. For example, if a cyclone went through an area, and actually saying, well, we need to rebuild, taking climate change into account because of the cyclone, but also very slow creeping changes such as sea level rise. Now, I don't know, it's not quite, this is slightly outside of my subject area, quite how that's going to happen. But I think allocating that funding in a fair manner is going to be extremely important, and it's also going to be very difficult to do, and trying to promote that equality between where that money goes is going to be very important. I think from what I've seen in other cases, when you look at where money goes, if you get somebody or a group of countries or a region that's very organized, either from an outside body or the governance itself, it can mean that it's more effective in terms of bidding for money and actually putting together a case for why funding is needed. So I think in that way, there may be winners and losers as well. But I say this is sort of on the edge of my subject area. I think there's lots of challenges there, but actually trying to think about how you can spend funds effectively is going to be very interesting and almost some way a challenging way in the future.
David, do you have anything to add on this? Yeah, so I would just add, Sally's mentioned the formal sources which are being built up basically as a result of the Paris Agreement and then through the various international processes. But there's also a large amount of funding, say from bilateral donors from countries that are increasingly putting funds into adaptation and climate mechanisms. And then there's also private foundations and sources that are doing that too. So I think it's certainly a growth area as it needs to be. And I think small island states and least developed countries can benefit a lot from that in the future. But I always want to put a caveat on that. It's still not an excuse for least developed countries to do all the wrong things now. I mean, we all have to plan according to what's going to happen, what we're predicting in 20, 30, 40, 50 years in terms of CO2 and sea level rise and things like that. So there is a very high responsibility on the part of all governments, all decision-making groups, to invest in the right way and in the most sustainable way to improve the lot of everybody, including themselves. I mean, there's leadership coming in particular from China in terms of energy, new energies and things like that that's happening because of internal to population and pollution and things like that. So I think, you know, it takes effort from all sides it will take effort from all sides to make it work.
So we're coming to an end of our discussion and conversation. I have one final question for you. Realistically speaking, Sally and David, how do you foresee the future of our coast? If we do everything right, for example.
Over to you, Sally.
I'm thinking, I don't think we will do everything right. I think that's one of the big challenges, is that we won't do everything right because there are pressures in terms of development. There are pressures in terms of competition and use of resources and use of space. I think one of the biggest challenges is to try and, I think another big challenge is learning. Say a colleague of mine working in a developing nation said to me earlier this year that they're mowing sand off the beach, which has the potential to increase coastal erosion. It does in that particular area. And they're doing that to get money, or trying to get money to feed their families and to build livelihoods, but actually preserve the coast at the same time. It's a very difficult argument to do. So I think we're in a future of challenges, and those challenges aren't going to go away. That's quite a negative note to leave on, but I hope that's sort of maybe food for thought for something else in the future.
Okay, well, from the perspective of coral reefs, we've been dealing with this negative messaging for quite some time because, I mean, many of us don't feel that the amount of climate change we're committed to really gives coral reefs much room for survival, certainly not as they used to be or as we have known in the last 20 to 30 years. The positive side is that, you know, the planet changes all the time. They're very populated landscapes that are beautiful, very nice to live in. So the key thing for a coral reef or for coastal systems is if we begin to understand the dynamics and make the right decisions to keep the system functioning in a good way with products and services, then we come out the other end and we could still have an environment that we want to live in that's clean, you can still get some fish from. It won't be like it was 30 years ago, but we can try and make it a clean, functioning ecosystem.
So if I conclude by saying the future we want to have is the future we make, would that also be applicable for the coastal regions that we want to see and have?
Yes, that's absolutely. For coral reefs, we can make what that system will become, for sure.
So I'd like to thank you for your time, and thank you very much for joining me on this conversation today. And I would also like to thank the participants who've posed a lot of questions and engaged actively. There will be all the questions on the chat box, and we will be able to pick up on some of the questions as well later on the forum. So David and Sally, thank you so much, and thank you for engaging, and thank you for being able to share your expertise with us.
Thank you very much.
Thank you.
Enjoyed it.
All right, take care.